arithmetic sequences. Do not forget to subscribe, and if you have any question, feel free to ask or suggest anything. A number sequence is a list of numbers in a specific order. In some sequences, the numbers have a regular pattern to them. Look at the sequences below. The dots mean that the lists continue forever. If we look at either the list of numbers, we will see that there is a pattern in each sequence. In the first sequence, we can see a pattern in these numbers. These numbers are the squares of the numbers 1, 2, 3, 4. In the second sequence, each number is the sum of the two numbers that come before it. In the third sequence, we go from one number to the next by adding 3. Pay attention. Each number in a sequence is called a term, and each term has a position. We can represent the terms of a sequence using the letter A and the position of each term in the sequence by a subscript number. Let's see how it works. Look at the sequence below. 5 is the first term, so the first term is symbolized by A sub 1. 8 is the second term, so the second term is symbolized by A sub 2. 11 is the third term, so the third term is symbolized by A sub 3, and so on. In general, we use A sub n to represent any term in the sequence. A sub n is called nth term and just means a generic term for which we haven't yet specified its position in the sequence. There are two major types of sequences: arithmetic and geometric. Now we will study arithmetic sequences. Pay attention to the following sequences. In the first sequence, we go from one number to the next by adding 3. In the second sequence, we go from one number to the next by subtracting 6. The patterns involve adding or subtracting a number to each term to get the next term. Sequences with such patterns are called arithmetic sequences. An arithmetic sequence is a sequence in which each term after the first is found by adding or subtracting a constant value. Look at the first sequence again. We can see that these terms go up by 3 every time. We can state that the common difference is 3, since the difference between consecutive terms is always 3. Look at the second sequence. We can see that these terms go down by 6 every time. We can state that the common difference is -6, since the difference between consecutive terms is always -6. The common difference of an arithmetic sequence is the constant difference between consecutive terms. The common difference is denoted by D. Suppose we take the following sequence: 5, 8, 11, 14, and so on. And we want to work out the 21st term. We can do this by adding 3 starting from 14 until we reach the 21st term. But it takes a long time, so if we found a formula, the task would be easier. It's possible to build up a formula to find a sub n, or nth term, for any possible n of an arithmetic sequence in terms of the first term and the common difference. Pay attention. Suppose the first term of an arithmetic sequence is a sub 1 and the common difference is d. We can rewrite this sequence as follows. The second term is the first term plus difference common. The third term is the second term plus the difference common. The fourth term is the third term plus the difference common. And so on. At each stage, the common difference was multiplied by a value that was 1 less than the index. Following this pattern, the nth term, a sub n, will have the form. This is the general term formula. Consider the sequence. Show that the sequence is arithmetic. In an arithmetic sequence, the difference between successive terms is constant. When we subtract a successive pair of terms and it doesn't matter which pair we pick, the result is always the same. So the common difference is 4. Find a formula for the general term a sub n. Substitute the values of first term and common difference into the formula. Use the distributive property and simplify. Find the 23rd term of the sequence. For the 23rd term, substitute n with 23 into the formula. What is the position of the number 83 in the sequence? Substitute 83 with a sub n into the formula and solve for n.